starting a new module. The module is Module 2, and it's called Developing Functions Foundation. We will learn what that word means later. We are in Topic 1, which is moving from proportions to linear relationships. Again, this is your overview, talking about the module, talking about the topic. And then we're in Lesson 1 on page M27. So it says represent proportional relationships with tables, lines, and linear equations. We're going to compare graphs of proportional and compare two different. So hopefully you guys have learned a lot about me so far. I don't like doing every single page. I think it's better to do a few problems. We will come back to those pages. I'll just be talking about the vocabulary words. So where I'm going to actually start doing our notes is on page M214. It's the 1.3 comparing speeds. So that's where I'm at. And we're going to do this problem over 2 lessons, I believe. I can't remember exactly. And that's on another piece of paper. So we are going to take some time to do this problem. We're going to do it in depth. So I'm going to say Desa. So Desa attends college in another state. During summer break, she drives home from college to visit her family and friends. She's going to keep track of the time it takes her to drive home from school, and she records it in this. So this is called a table. So she represents it in a table. And then over here, you're going to see this is Timar, and his is in a graph. This one is a third friend, Alicia, and she's going to use this as an equation. But we're just going to talk about this one for now. For right now. So, does this table represent a proportional? So you see all of these questions. I'm just going to do what we're going to use this table for in Math 8. So if we look at this table, it says time 3 hours, distance 180. So when on Desa's drive home, when she was 3 hours away, she had traveled 180 miles. That's what that's saying. After 2 hours, she had done 120 miles, and I really don't like the fact that her table says 3 hours, then 2 hours, then 1.5, and then 2.5. Did she go back and figure it out? So I'm going to put my table in order. So I'm going to do this again, but I'm going to put it in order. So I want you to do the same. Time, distance. Okay. So the lowest number we have 3, 2, 1.5, and 2.5 is 1.5. So I'm going to put that one first. And I'm going to put the value that goes with 1.5 next to it. So these need to stay together as a pair. Then we have 2.5, 150. Then we have, and then I mess up. So if you have to, just mark it out and do it again. I'm going to erase so that it's not messed up. So then it's 2, 120. Remember, keep those together. 2.5 is 150. And 3 is 180. Okay, so we're actually going to ignore these parts for now. We're going to find the unit rate. So what I call, and what our vocabulary for our topic is actually going to call that, is rate of change. So if we were talking about Desa and we were wanting to know how fast or how slow or how fast was she traveling? Remember, when we talk about how fast someone's going, you normally talk about miles per hour. So if I want to know how much she's changing, notice, and I'm going to get another color, or I'm going to get a different color just because that's the way I do things, and I'm going to open the calculator on my phone. Okay, you could use the one on your computer, but I'm going to use the one on my phone. So I want to figure out how much distance did she travel in this amount of time. So if I'm going from 90 to 120, and I want to figure out how much that is, you could count if you want to, or you're going to take the 120 and subtract the 90. 120 minus 90 is 30. Now, the reason that you don't go the other way, 90 minus 120 would give me a negative 30. She didn't go a negative distance or negative miles. She went a positive miles. Okay, now let's see how much time changed. So if I went from 1.5 hours to 2 hours, hopefully you see that's 0.5. Or again, you could subtract. So you would do 2 minus 1.5. 2 minus 1.5 is half an hour. So she went 30 miles in half an hour. Okay, let's do this next one. So again, you're going to take this ending, so where she stopped, minus where she started, and that's going to give you the difference. So that's also 30 miles. 2 to 2.5, well, that's also half an hour. 150 to 180, I bet you is going to be 30. 0 minus 0 is 0. 8 minus 5 is 3. So yes, it would be 30. And then 2.5 minus 3 is also 0.5. So hopefully you see in that that is, she's going the same rate. So she's going 30 miles in half an hour. Does anybody ever hear, like, do you ever hear your parents, your grandparents, your aunt, your uncle, or anybody ever talking about you are going 30 miles every half hour? Well, no, because we always hear them talk about miles per hour. Your speedometer in your car is going to tell you your miles per hour. It's going to say mph. So if I'm going 30 miles in half an hour, well, I would have to go 2 half hours to make 1 whole hour. So I would have to go 30 miles, which would be 60 miles. So it would be 60 miles in 1 hour. Now, watch how, because if this said like 2/3, or if this said 0.8 or something weird like that, and you wouldn't want to try to figure that out, what you can do is you can do 30 divided by 0.5, and you're going to get 60. So 30 divided by 1/2 hour is going to give you 60 miles per hour. A little bit of a side note, when you do 30 divided by 1/2, remember when you divide a fraction, you would do 30 and you would change it to times, and you change it to 2/1. Now, if you don't remember that, it's no big deal because, again, we have calculators. So we're going to do 30 times 2 is 60, or 30 divided by 0.5 is also 60. So her rate per 1 hour, so see how it said per 1 hour, is 60 mph. So that's how fast she's going. Okay, now let's look at Tamar. So one of her high school classmates, Tamar, attends college with her. He also drove home for summer break, but takes a different route. So he went a different way, and he probably went at a different speed if he wasn't following her. So, who drives faster, Desa or Tamar? We want to know, and in order to do that, we need to know Tamar's mile per hour. Well, I don't know about you, but looking at a graph kind of overwhelms me. So I'm going to zoom in so we can actually see the graph and focus it. Sorry, I moved it. And I'm going to turn off this light. Hopefully it's not loud, but just so that we can see it a little bit better. Okay, so now when we look at this graph, I personally like looking at tables, and we want to compare the two, so you're going to have them in the same form. So I'm going to make a table. So if we look, we're going to say time, because time is along this x-axis, and we always put x in the first column. Then distance is on the y-axis, and that always goes in the second column, so distance. Okay, now this is just a graph. What always messes people up is that it's not a whole bunch of points, like there's not a point here and a point here, like let's say there's a point there. So what you actually want to look for, we know that it started at 0, 0, so I would put that point, 0, 0. There was a time of 0, he had traveled 0 miles. Now you're going to look along this graph. So if we tried to figure out what that point was, I would have to estimate, because notice it's not exactly on, I call these grids, or the T. So I would have to say, well, that's 20, well, halfway between those would be 30. That's a terrible 30. And so this is somewhere in between, so maybe it's 25, but I don't know for sure. So what I'm going to keep going is I'm going to move along this line until I get to a grid like that. So I know that point right there, and I don't have to estimate it. So at 1, a time of 1, Timar had traveled between 40 and 60 exactly is 50. So I would say 1 hour is a distance of 50. Okay, then I'm going to keep moving along the line till I find another point, and right there is where it crosses the grid again. So then I would say 2 and 100. Then I'm going to keep going, find the next one, and it would be 3. Between 140 and 160 would be 150. Keep going until I run off of the graph. Well, there's not another one, but if you look at that arrow right there, it would hit. Oops, sorry, you couldn't see it. If you look at that arrow, it would hit again right there. So that would be 180, 190, 200. So 4, sorry, I'll move this up. 4 is 200. Okay, some of you guys probably are quick enough at math that you already know how much the distance is. So notice this one is changing by 1 hour. This side is changing from 0 to 50. 0 to 50 is 50. 50 to 100 is 50. If you don't just know that, again, you could do 100 minus 50. 100 minus 50 is 50. Okay, we are going to set up the distance over time. So distance over time. The distance was the y, time was x. Oops. And so for Timar, we would say 50 divided by 1. He was going 50 miles per 1 hour, or 50 miles per hour. So if you divide 50 by 1, you get 50. So then if we look, Desa was going 60 miles per hour and Timar is 50. So who's going faster? It was definitely Desa. Okay, so again, we took these points off of this graph and we put it here. I do want to write in our notebook rate of change. So this was, we're starting, I'm just going to put rate of change. You could title the notes that too. So rate of change is the amount to quantities are changing by, and it's always per 1 unit. So that's important that you remember that it's per 1 unit. This is also called unit rate. You might have heard that last year. So also called unit rate, rate of change. So in this case, we did distance, which was the y value, over time, which is x. I do want you to write this note just so that we have it for future reference. So we're going to say the rate is always set up as change of y over change of x. And it is very, very important that you, if you have a highlighter, I don't have one in front of me, but I'm going to put a little cloud bubble so that whenever I'm going back through, I see that. That right there means over or divided. Okay, one last thing. No, actually, I'm going to stop there. So change of y over change of x. It was distance divided by time. Miles per, which is what that means right there, hour. So it was miles per hour. And that is rate of change. So again, we took our graph and we changed it into a table. This one was already set as a table, and we just found the amount that it was changing by.